No, he and I have a meeting about something completely unrelated to this today.
Oh, so you're just, this is just.
I just would like if he'd walk in and we were like having a nice conversation about the content.
Wait, he's coming today.
Yeah,
Oh, I
at the end of the
thought
day.
it was like
Are you talking about letting us do the both as our final as a project instead of final exam?
Oh, that is such a good idea.
Honestly, I think that's what you're doing because we're in the lab, and I said,
What would you do if your boat sank?
so I
We're not doing the boat thing?
No, we are.
If my boat's missing, I might just stand up, give a salute, and slowly
I
sink
go
into the
down
water.
with my ship.
I'm going captain. Steve. What do you think?
So like 0
Yeah.
All right, are you ready?
It's like slowly.
So from your lab notebooks, I'm going to ask you some questions. Get ready in case I ask you a question.
I'm not ready for that.
Are you ready?
Just like don't call on me when you're.
They're not cold. They're not cold. Everybody's warmed up now.
I'm cold.
These are
We didn't do it.
these are
So when you
semi-warm.
guys-
We didn't do check-in, but it did, so my brain's not like.
Like, what do you want us to do? Can we make you look good?
Lauren,
Oh.
Good luck.
did you guys do a lab?
Yeah, we did.
Okay. Did you draw the lab in your notebook?
Yeah.
What did you guys graph on the horizontal axis?
No.
I don't know.
Oh, we didn't draw the graphs.
What?
We have them on our whiteboard.
Yeah, we did. The graph you
No.
You guys didn't draw.
Oh, he
We
drew
had
it.
feet area.
All I have on here is.
Area.
All I have on my board is velocity.
Oh, no, yeah, that was change of velocity. Sorry, I was talking about the
No,
y.
I know. You're good.
My fault.
Jacob, I appreciate it. Yeah. What's on the vertical?
The feet area.
The force
Force.
times
Area.
area. Okay? So the thing that we are transitioning to is it's not just the amount of force now, it's the amount of force and the duration that that force lasts. That's the thing that we're considering. Okay? So that's what's on this axis. Now, you guys did the lab, yes? Okay? Grace, is it your birthday?
Yeah.
Happy birthday.
Thank you.
What kind of relationship did you guys come up with here?
Olivia.
Fantastic. Zero intercept?
Yes.
Okay. So this is I think everybody did this. Okay? This is cool. What are you doing, man?
Writing.
There's like one rule. Don't write. Right? Just chill out, man. You're good. Just chill out.
Wait, you're getting a.
Trying to be
He's trying to make you look good for Mr. Bishop.
Just
Yeah.
sit there and pay attention. That's all we need from you, man. That's all we need from you. Okay.
Should I put a cast on?
Not super effective. All right. What is the general form for a straight line?
Y equals mx.
Still scratching.
Whoa, why is it so spread apart?
All right, so let's look. What's on our y-axis? Annabelle, what's on the y-axis?
The y-axis?
Yeah,
That would be the area.
good. It's the force time area. Okay. All right. Charlie, what's on the x-axis?
Change in velocity.
Okay.
Yeah.
Stop doing that. All right. What's the intercept here? Zero. And we're good with the fact that all of our intercept values were really close enough to 0. And then this is right at the end of the class period yesterday. We realized that the units.
Oh, it was.
Okay. That's right. We realized that the units were kilograms, which means, what do you think the slope represented for you guys? It was the mass, and then Brendan massed the car. Was it close enough to your slope that you would buy into it?
Yeah.
I felt good about that. So this is the mass. And so this mathematical,
Should we write this down?
I would. This mathematical construct
Say that every time.
comes from the lab that you guys did, right?
I don't want to write something down.
Like, it didn't come out of thin air. I didn't make it up. I'm literally writing down what you guys had on your boards. Does that make sense to you?
Yeah.
Now, this is also a proportional relationship, which means if you wanted the delta V, the change in velocity, to double, what would have to be true about your force time area? It'd have to double as well. And if you use the correct cause and effect here, if you doubled your force time area, you get twice the change in velocity. Is that cool?
Yeah.
Now, one thing that we understand is that this is the force time area of the little graph. So you guys had a little graph that looked like this, where it plotted force and time. And this area here was the thing, right? So we have to consider not only the amount of force, but how much time that force is applied. Okay? Oftentimes, we actually see this written, instead of writing force time area, we often see it as this. We often see it as the force times the time over which the force is applied, okay, is equal to the mass of your object times the change in velocity of the object. So this is the, what we call the net unbalanced force. Okay? That's the net unbalanced force. And this one is the duration. That's how long the force lasts. Okay? So if you see this word net force or net unbalanced force, it's the fun ball that we were working with. Is that all right?
Yeah.
So far, so good? We also looked at the units. This is newtons times seconds. And over here, this one is kilograms times meters per second. All right, that's the summary of the lab. Are you guys comfortable with that?
Yeah.
Mm-hmm. Now what? Now what?
Checking question?
No.
Card trick?
Why'd you say it like that?
I'm working on one.
Really? Let's
Can
see
you
it.
teach me one? I've never been
Let's
a
see it. Assessment A.
I'm a little bit of
I'm working on it. I'm still training, man.
So, you give us quizzes when we're still working on our skills, and then we reassess.
That is true. That is true.
You got you.
But I'm not even there. I'm not even close.
So, that's me.
Wow,
I'm close to the
those are
first assessments.
Well, my parents are gonna get so upset if I get a bad grade.
They do.
Well, then we won't put it in the grade book.
That sounds.
Yeah, what if you just gave us all hundreds?
Yeah. Have you seen?
I'm kind of feeling that.
Yeah, they came out. Yeah, it's a C.
Because my reassessment hasn't been graded yet.
I know.
I'm waiting.
I'm pausing, man. I'm working on it. I don't have. I got to take Marshall to practice tonight. I will have some time to do some grading.
Good.
Oh, I got like 94.
The end of the quarter was so like jam packed with stuff that I got a little bit
Well, there was
Someone
overwhelmed.
said it was so last month or something.
I'm taking long. Okay. There are.
It's fine, as long as I don't.
This is actually a very cool conceptual framework that we can actually apply to situations that like you understand from your everyday life, which I think is super cool. Okay?
Yeah.
So I'm going to draw a picture and let's see if we can figure out what it is.
Oh, like Pictionary.
A stick.
Okay.
There's one in
Does whoever guess get to draw on the next picture?
Tree. Flip.
Tree.
A flag.
A plane.
Like a graphic design.
A flag. A rocket ship. Elon Musk.
Yes.
Diving board. Good job.
A diving
Oh
board?
my god, well it can't help that I can't see the colors from this.
Yeah, he's colorblind.
Is it a high dive? You just jump it in.
It's a 5 meter. It's a 5 meter board.
You could wear your colorblind glasses.
All right.
Is he gonna do a?
Ready?
Okay, I got
Here's where we are.
He's gonna dive. Is it drawn to
Well,
scale?
he's not in the diving position.
Not quite. Actually, it's pretty close to be honest.
Actually,
Now,
He's gonna go off the wall.
reset please.
Alright.
our guy's gonna step off the board. Now, if it's a 5-meter board, how much time is it gonna take him to get to the ground?
How much does it weigh? Oh wait, never mind, that's in 1 second.
Good, you look at the wall, it's 1 second,
I was like,
right? How fast is he moving when he hits the water?
5 meters per second.
No, remember, so 5 is the distance, but how much do you speed up every second? 10, that's right. So after 1 second, you've fallen 5 meters and you're moving at
50?
10 meters per second.
Wait, what? I'm confused.
Now, normally, when you step off the platform, you're just going to jump into the water and everybody's
If you're
winner.
falling at 10 meters per
Okay.
second. If you're falling at 10 meters per second and it's 5 meters.
You fall at, so you're falling, not at a constant speed. Remember, you're speeding up the whole time.
Yeah.
For every second that you fall, you speed up an additional 10 meters per second.
Oh, so he's going.
So if he starts from rest and he falls for 1 second, when he hits the water, his speed is
10.
10 meters per second.
oh,
So
he's-
when he hits the water, 10 meters per second. But then you come to a stop underneath the water, true?
Yes.
So is there some change in velocity from when you hit the water to when you stop?
Yes.
Fantastic. Feel great about that.
Force of water on human.
You have another option. Okay? You have another option here. You could jump onto the concrete.
Oh, I would.
Now,
Who the heck does that?
You would not be smart to choose
I would not suggest this.
No, maybe they're just going.
Or the, is it like the
5 meters.
splash mark?
How would you even
It's
get?
like jumping from the ceiling down
This flat mark?
Yeah, do not do that.
Around.
He flops on it.
You could land on. Does he land on his feet?
Don't let anyone.
Here's
near
what I
your
want to
next
know.
Well, you would break his feet.
Given
Oh,
this
it's only
framework,
5 meters. Oh.
DIY.
You need some extra.
Jumping from that deep right there.
That's so rude. At that point, I wasn't even yelling at you for doing that. because you're all-
I'm like, that's
the top of the stairwell is about 7 meters. So when you're from the 3rd floor down to the 1st floor, it's about 7 meters. All right. Listen closely, please.
That is so.
Listen closely. Here's what I want you to do. Obviously, one of these is better for you than another. I would like you to use this. Some kid last hour was like, "You mean fat math?" It took me like the whole hour to figure out what he was talking about. So, using this fat math mathematical framework, tell me why it's better for you to jump into the water than it is to jump onto the concrete. Check
Because the water is not
The
water I'm like, how is this so?
It's less than like.
So this is like this is like 3 Yeah.
Yeah, that would make more sense.
All right.
Survive that.
Answer the question, man. Answer the question. You got it?
Well, because the water gives you
got
down.
it?
As opposed to.
Wait, can you repeat that? You said water. Explain that.
Oh, I got you. So with concrete,
How much does he weigh?
slowing down, it doesn't matter how much you weigh.
Ow! There's massive equations. How much does he weigh?
Doesn't matter.
So that way it's flat, but if you go into the water.
Good, it would be a gradual slope.
All right, you ready? So,
But we don't know the mass.
it doesn't matter. Because in both
And it's
situations,
in the equation.
right.
Right.
But here's the deal. You have the same guy, so the same mass, and you have the same change in velocity. He hits the water at 10 and comes to a stop. Here, he comes to a stop somewhere underneath the water. Here, he comes to a stop on the concrete. What's the difference between those two instances?
One's abrupt and then one is gradual.
So they both said the same thing with different words. She said one is abrupt and one is gradual, and she said the time is different. So let's look at the FT area graph. Okay,
Well, I thought that was
let's do the water, right? When he hits the water,
maybe my ears don't work very good.
Okay? When he hits the water, the time is spread out, true?
Yeah, true.
Yes.
But what does the graph look like when he hits the concrete?
Flat. Oh, yeah. Okay, well, that's a little drastic. I feel like it should be.
So what's true about the areas of those two humps?
Same.
The areas are the same, but which one is applying much more force on you? So the reason that you jump into the water is it, and you may want to write this down,
Oh, God.
it increases the stopping time, which decreases the stopping force. So even though the m delta v is the same, for the water, it has a small force that lasts a long time. But for the concrete, it's a large